Lesson: Middleware for AI implementation. Middleware plays a crucial role in AI implementation by serving as a bridge between various software components, ensuring seamless integration and communication. As AI systems become more complex and widespread across different industries, middleware becomes indispensable in managing these complexities and facilitating efficient interactions between disparate systems. Middleware can be understood as a software layer that offers services to applications beyond those available from the operating system, providing a framework that allows for the integration of multiple, often heterogeneous, systems. This lesson delves into the practical applications of middleware in AI implementation, offering actionable insights, tools, frameworks, and step-by-step approaches that professionals can utilize to overcome real-world challenges. Effective middleware solutions for AI implementation must address several key requirements: interoperability, scalability, security, and data management. Interoperability is critical because AI systems often need to integrate with existing systems built on different technologies. Middleware can provide common communication protocols and data formats that enable these systems to work together. An example is Apache Kafka, a distributed event streaming platform used by thousands of companies for high-performance data pipelines, streaming analytics, and data integration. Kafka's ability to handle real-time data feeds makes it an excellent tool for AI applications that require processing large volumes of data quickly and efficiently. Scalability is another essential feature of middleware in AI systems, particularly as the volume of data and processing demands increase. Middleware solutions like Kubernetes, an open-source platform designed to automate deploying, scaling, and operating application containers, offer robust scalability features. Kubernetes allows AI developers to manage containerized applications across a cluster of machines, providing a resilient and flexible environment that can adapt to changing workloads. For instance, in a case study involving an e-commerce platform, Kubernetes was used to scale AI-driven recommendation algorithms to handle seasonal spikes in user traffic, ensuring that the system could manage increased loads without degradation in performance. Security is a paramount concern when implementing AI systems, as they often deal with sensitive data and critical operations. Middleware can enhance security by providing authentication, authorization, and encryption services, thereby safeguarding data as it moves between different system components. An example of a middleware security solution is OAuth 2.0, an open standard for access delegation commonly used to grant websites or applications limited access to user information without exposing passwords. By implementing OAuth 2.0, organizations can ensure secure communication between AI systems and other applications or services, reducing the risk of data breaches. Data management is another critical aspect of middleware, as AI systems rely heavily on data for training models and making predictions. Middleware can facilitate efficient data integration, transformation, and storage, ensuring that AI systems have access to high-quality data. Apache NiFi, for instance, is a data integration tool designed to automate the flow of data between systems. It provides a user-friendly interface for designing data flows and supports real-time data processing and comprehensive data provenance. In a healthcare setting, Apache NiFi was used to integrate patient data from various sources, transforming and cleaning the data before feeding it into AI models for predictive analytics, ultimately improving patient outcomes. In implementing middleware for AI, professionals must adopt a step-by-step approach to ensure successful integration. The first step involves assessing the existing IT infrastructure to identify potential integration points and determine the specific requirements for middleware. This assessment should consider factors such as the types of data being processed, existing communication protocols, and the scalability needs of the AI system. Once the requirements have been identified, the next step is to select appropriate middleware solutions that meet these needs. This selection process should involve evaluating different middleware options based on their features, performance, and compatibility with existing systems. After selecting the middleware, the next step is to design the integration architecture. This involves mapping out how different system components will interact and defining the data flow between them. Tools like Enterprise Service Bus can be used to facilitate this process by providing a centralized platform for managing data flows and orchestrating interactions between services. For example, in the financial industry, ESB has been used to integrate AI-driven fraud detection systems with legacy banking systems, enabling real-time monitoring and analysis of transactions to identify suspicious activities. Once the integration architecture is designed, the next step is to implement and test the middleware solution. This involves configuring the middleware to meet the specific requirements of the AI system and conducting thorough testing to ensure that all components communicate effectively and that data flows seamlessly between them. Testing should also include security assessments to ensure that data is adequately protected and that the system complies with relevant regulations. Finally, ongoing monitoring and maintenance are essential to ensure the continued effectiveness of the middleware solution. This involves regularly reviewing system performance, identifying potential bottlenecks or issues, and making necessary adjustments to optimize operation. Tools like Prometheus, an open-source monitoring and alerting toolkit, can be used to track system performance and generate alerts for any anomalies. In a logistics company, Prometheus was used to monitor an AI-powered supply chain management system, providing real-time insights into system performance and enabling proactive issue resolution. In conclusion, middleware is a critical component in the successful implementation of AI systems, providing the necessary infrastructure to integrate disparate components, manage data, and ensure scalability and security. By leveraging practical tools and frameworks such as Apache Kafka, Kubernetes, OAuth 2.0, Apache NiFi, Enterprise Service Bus, and Prometheus, professionals can overcome the challenges of AI system integration and enhance their proficiency in this area. Through a systematic approach that includes assessing existing infrastructure, selecting appropriate middleware solutions, designing integration architecture, implementing and testing the solution, and ongoing monitoring and maintenance, organizations can effectively integrate AI systems into their operations and unlock their full potential.